And now let us summarize what we have learned so far in the graphical analysis. And that is, if we have a displacement time graph, so the slope or the gradient of a displacement time graph gives us instantaneous velocity, whereas the slope of a velocity time graph will give us the instantaneous acceleration. And if we need to go in the reverse direction, so for example, if acceleration time graph is given and we need to figure out the change in velocity, so we will find the area under the acceleration time graph. Similarly, the area under the velocity time graph gives us displacement. And now let us try to analyze different types of graphs based on the types of motion. So the next topic is acceleration time and velocity time graphs for different kinds of motion. Case 1, stationary object. So we need to determine the shapes of the graphs for displacement time, velocity time, and acceleration time. Now, if the object is stationary, the displacement is constant, which means the displacement time graph will be a horizontal straight line. And since the object is stationary, of course, the velocity will be zero. So the velocity is a horizontal line passing through the time axis, which suggests that velocity is always zero. Similarly, if velocity is zero throughout, acceleration also will be zero. As you can see here, acceleration is a horizontal line passing through the time axis. Similarly, let's consider case number 2. If the object is moving with a constant positive velocity, how will the graphs look like? Since the velocity is constant, so the velocity time graph at least will be a horizontal straight line. But what about displacement? If the velocity is constant, then displacement increases with time at a constant rate. That means the graph will be a straight line passing through the origin. For velocity, it's simple. All we need to do is just draw a horizontal line that will indicate that the velocity is always constant. Now, since the velocity is positive also, that's why the velocity graph is above the time axis. And what about acceleration? Remember, acceleration is the rate of change of velocity. Here, the velocity is not changing, which means the acceleration, even in this case, will be zero. So you can see acceleration time graph is a horizontal line passing through the time axis. Case 3, constant negative velocity. So velocity is constant, so it will be a horizontal line. But since it is negative, so it will be below the time axis. But what about the displacement time graph? Since the velocity is negative, so we can say the particle is going to the left hand side. Hence, the value of displacement is actually decreasing, but at a constant rate. Why the rate is constant? Because velocity is constant. Hence, in this case, if we have constant negative velocity, the graph of displacement time will look like this. It's a straight line, but the graph is continuously decreasing, or we can say the gradient or the slope of this graph is negative. In the previous case, if you observe this graph, the gradient of this graph is positive, which signifies the velocity is positive. Back to case number 3. What will be the velocity time graph? It will be a horizontal line, but below the time axis. Velocity is constant, but it is negative. That's why the velocity graph is below the time axis. And for acceleration, just like the first two cases, acceleration here also will be zero. Because remember, acceleration is nothing but the rate of change of velocity. In case 3, even though the velocity is negative, but it is not changing, it is staying the same throughout. That's why the value of acceleration is 0. So these were the three cases where acceleration was 0. Now let us consider situations where the particle is accelerating. Case number 4, the particle is having a constant positive acceleration. Since the acceleration is constant and positive, hence we can easily draw the acceleration time graph. Acceleration time graph will be a horizontal straight line, but above the time axis because the acceleration is positive. Hence, the acceleration time graph will look like this. Now, how do we draw the velocity time graph? So, for that, remember, acceleration is nothing but the rate of change of velocity, which means if acceleration is constant, that means the rate of change of velocity is also constant, which implies whatever graph we draw for velocity time, the gradient needs to be constant and positive. Hence, the velocity time graph will be a straight line having a positive slope. And now, what about the displacement time graph? What do we do to do that? What do we do? How to draw a graph for that? Now, remember to draw the graphs, it is easier if we can get the equation of the displacement. So now, if you recall the displacement, Now, if you recall the Stewart equations, S is equal to ut plus half at squared. Here, S is the displacement, u is the initial velocity, and t is the time, a is the acceleration. If you analyze this equation, this actually is a quadratic equation, which we can write as y is equal to ax plus bx square, where a is u, the b value is acceleration upon 2, and x again is the time. Hence, this is a quadratic equation in t. And do remember, and remember, whenever the equation looks like this, we have a positive coefficient of t square. Acceleration is positive, so we can say a by 2, which is the coefficient of t square, that is positive. So whenever the coefficient of t square in a quadratic is positive, then the graph is an upward facing parabola. And hence the graph of displacement time graph will look like this. It's an upward going parabola. It is an upward facing parabola. Now, let us consider one more variation of the same constant positive acceleration. Acceleration is constant and positive, so acceleration time graph will always look like this. But velocity time graph, that is a straight line having a positive slope. So that line can be drawn even like this. Which means if the graph of velocity time looks like this, then initially at t is equal to 0, velocity is negative, which means the particle is going to the left hand side. Eventually, observe this graph, the velocity will become 0. So the particle is going left hand side, it stops for a moment. And now look at this graph. After this point, the velocity is positive, which means the particle after stopping changes direction and then it goes towards the right hand side. But remember the basic logic, the velocity time graph will be a straight line having a positive gradient because the acceleration is positive. Now, similarly for displacement time graph, remember the acceleration is positive, hence the graph needs to be an upward facing parabola. Hence the graph can also look like this. The only catch, how do we figure out which graph is correct? That determines on t is equal to 0, the origin point. Let's say we assume that at t is equal to 0, displacement is 0, which means this graph would be correct because only in this graph you can see that at time t is equal to 0, displacement is 0. On the other hand, let's say if we assume at t is equal to 0, displacement is some positive value. Then in that case, this will be the graph. As you can see at time t is equal to 0, displacement is non-zero and it is a positive number. So displacement decreases, it goes to a point. So the displacement decreases and then it increases back again. This also signifies that the object is changing direction. So this was the complete analysis of constant positive acceleration. What if the acceleration is constant but negative? How will the graphs look like then? Now, since the acceleration is constant but negative, so the acceleration time graph will be a horizontal line but below the time axis. Below because the acceleration is negative. And since the acceleration is negative, and acceleration, if you recall, is nothing but the rate of change of velocity. If acceleration is negative, that means the rate of change of velocity will also be negative. Hence, the velocity time graph needs to be a straight line, but having a negative gradient. And that's why the graph of velocity time graph will look like this. It's a straight line passing through the origin in this case, but it is having a negative gradient. Now, how to draw the displacement time graph? So, in the previous case where we saw acceleration was positive, we drew the upward facing parabola. Whenever the acceleration is negative, the equation for displacement will still be quadratic, but the coefficient of t square will be negative since the acceleration is negative. And remember, whenever the coefficient of x square in a quadratic is negative, then the graph is a downward facing parabola. Hence, the displacement time graph can look like this. But this graph has been drawn assuming that at t is equal to 0, displacement was 0. The only thing we need to focus on is the shape of the graph. So if you look at the constant positive acceleration cases, both of these graphs are upward facing. In this case, again, it's a negative acceleration, so it's a downward facing parabola. Let us consider another variation of the same constant negative acceleration. The acceleration time graph will stay the same. It is a horizontal line, but below the time axis, velocity time graph will be a straight line with a negative gradient. Why negative? Because acceleration is negative. Hence, the velocity time graph can look like this. This is also a straight line having a negative gradient. But in this case, at t is equal to 0, the velocity is not 0. It is some positive value. So what is actually happening? The particle is traveling to the right hand side, but the speed continuously reduces until it becomes 0. So the particle is traveling to the right hand side, it slows down and it stops. After that, it changes the direction and then it speeds up in the other direction. That's what the graph is representing. This is that point where the particle becomes at rest, and then the velocity you can see is increasing, but in the negative direction. That's why we say the particle is going to the left hand side. For displacement time, remember the basic logic, acceleration is negative, so the shape will be a downward facing parabola. Hence, the graph will look like this. And again, how do we differentiate the shape of displacement time graph? In this case, it has been assumed that at t is equal to 0, displacement is 0. And that's how we draw different types of graphs for different situations. Now, in the exam situation, it is a little tricky and difficult to memorize the different kinds of shapes. And that is why, for an exam situation, now we will understand what is the shortcut to remember the shape of the following graphs. And two types of graphs we'll be drawing. First is the displacement time graph and then the distance time graph, starting with the displacement time graph. So the shortcut is if the acceleration is positive, then the shape of the graph is upwards U. So have a look at different kinds of graphs which are upwards U parabola. If you analyze very carefully, all of these constitute a part of upward facing parabola or an upwards U. So the first graph is just one half of an upwards U. The graph 2 is complete U. And what's going on in this example case 3? So this part is the second half of the U and this is the first half of the U. But overall, if you analyze, all these three graphs are of the shape of an upwards U. And in the exam situation, if the graphs look like this, you can automatically deduce that the value of acceleration is positive. On the other hand, if acceleration is negative, then the shape of the graph will be downwards U. So have a look at these three types of graphs. So all of these three graphs are parts of a downward facing U. So over here, you can see this is a complete U. This graph is actually the second half of the U, the downward facing U. This particular part is the second half of the downwards U, and this particular region, this particular graph is the first half. So whenever in an exam question you see graphs like this for displacement time, automatically you can deduce that the value of acceleration is negative. So that was the shortcut for a displacement time graph. Now coming to how to draw the distance time graph. So what is the shortcut for a distance time graph? And that is if the object is accelerating, then the shape of the graph is an upwards U. For example, the graph will look like this, upward facing parabola. But if the object is decelerating, then the shape of the graph is downwards U. So you can see, look at this graph, it's a downward facing parabola. And this is how you read a distance time graph. Now let's take another situation where the distance time graph looks like this. So I have labeled 3 points A, B, and C. Now, if you analyze carefully, AB is a part of a downward facing parabola. BC, on the other hand, is a part of an upward facing parabola. Now, since AB is a part of a downward facing parabola, so the object will be decelerating. So we can write AB, the particle is decelerating. And in BC, since it's a part of an upward facing parabola, so the object will be accelerating in BC. Similarly, let's consider another situation where the graph looks like this. Here, AB is a part of a upward facing parabola. So AB will be accelerating. And BC is a part of a downward facing parabola. So BC is decelerating. And this is the shortcut which you need to know to solve exam questions. But please do remember one important difference between distance and displacement. Displacement is a vector quantity, it can also go negative. But distance, on the other hand, cannot decrease. It's a scalar quantity, it's a number. So distance will be positive and it will keep on increasing even though the particle might be changing directions, but distance always increases. And now let's summarize what we have learned so far. If we have a displacement time graph, the acceleration is positive when the shape of the graph is upwards u. Acceleration is negative when the shape is downwards u. For a distance time graph, the shortcut is if the object is accelerating, then the shape is upwards u. And if the object is decelerating, which is negative acceleration, then the shape is a downwards u. And please do remember these shortcuts while solving the exam questions.